what we were on last time was trying to figure out this continuation monad transformer. Or not transformer, my goodness. We're going to talk about transformers here in a second. But the isomorphism for this continuation monad. So, there we go. So what we're trying to do is basically prove that there is an isomorphism between A and this continuation passing, what is it called? Continuation passing style function. But we were having trouble writing what were we having trouble with? We were having trouble writing our type signature. So we need to think about how we deal with the type signature here. Now, if we look at this, this is supposed to produce apparently an any to any, which I think is supposed to be like no. I'm having a really hard time writing these compositions. If I just do this, what does this look like? Okay, so let's write this explicitly. So what I want to be able to do is prove that this is isomorphic by composing it and actually checking it instead of just guessing. I think it is, looking at it. If you basically assume that R is A, then if you give this an A and make this and then go back to the A, it should produce the same thing. But it's really hard to know for sure. So I'm trying to prove it via some sort of check. We'll see if we can. All right, so this is this, right? And the type of dot. What are you doing, kitty? Scared me. Is this. Do. Okay, so what do we have here? Then we're gonna have this. We need to be able to write this. B. Is this whole thing B to C? So this thing needs to, it looks like to me it needs to take an A and produce an A to A. But that's not right, and I don't know why. Right, because this B to C We're going to take an A to a B to a C, and we need an A. And we should get id back. Well, we should get that back. That's C. I just don't know how to do this. We had a hard time with this last time. There's some sort of for all in here that we need. I just don't know what it is. Expected type A to A naught. Yeah, and then that says that the type is basically this. And like, I don't understand how to get this correct. Because every time you see something like that. So A to R. To A to R to R. Okay, so we'll write exactly that. See, and then as you start doing this, it starts getting simpler. I just don't understand how to write this. Hey, Brador. What's going on? How did you enjoy the earlier stream? I don't know how to do this. Looking at the types, however, it does look like we're gonna get A to A, which is id, so we're good to go. But I don't know how to actually write the type to make this thing compile. Does it compile the other way? Lumi's back too. Everybody's back. How's it going? Yeah, it hates that embedded for all. I need to deal with it. Oh no. I'm sorry. It's pretty complicated for me as well. I've not done a lot of it. I've done just enough that wasn't completely over my head, basically. But I do think it's very interesting. So it's pretty clear to me that I can see that I'm gonna have A to A, right? If we just compose them. But what I really don't understand is how to actually write. So last time we had an issue like this, we just gave it F. And it kind of just worked, right? That's what we were doing before. But that doesn't work here. This is weird. Why does it say A to A1? I'm having a really hard time understanding what this is doing. That's not the type. Kata streams sound. Just try writing compose without dot operator. What other operator do I use? $sign? Oh, okay, that's fair. I see what you're saying now. Sorry, I'm. So is the type signature supposed to be this thing to this thing? Like, what is P? This is the part that blows my mind. Like, what is this P? I mean, clearly this is going to be the input to this function. Is the output the same? Am I supposed to just write? Oh my goodness. Okay, maybe I was overthinking it, but I thought that this would just be A to A. But I guess not. So the real question is, can I get rid of this and just write it in dot syntax? And is it the same or not? Because it might not be. Why is my watch going crazy? I don't need to relax, little watch. The other one is A to A. Okay. And yes, you can't write it as a dot. You have to explicitly write it as a lambda, which is why I probably never would have gotten this. So thank you. Okay. So this one is supposed to be. Oh, Redder, sorry. I did read it and then I got distracted. Held a message. That's weird. I've never seen. What is this automod thing? Apparently your thing got modded out, Lumi. Also, Kata streams? I don't know. What do you guys think about Kata streams? I tried doing that once and it wasn't well viewed. So I tried doing the that one kata, and it wasn't well viewed. Although, to be fair, I guess it's never viewed very well late at night. Also, hello, world sender. Interesting. But I really don't know how I feel about kata streams, because I don't know. It's definitely interesting. So this should simply be A to A. I don't need a for all here, and I probably need to do something like this. Bam. And it just kind of works. That's okay. And apparently we can write it in dot syntax if we use a new type, which we're gonna write here in a second. So maybe we'll try doing that. But let's so what's the next thing we need to do? So I need to prove that this is actually correct by giving this thing an argument. So I need to apply this to something. Why are you using lambda syntax though? Because it doesn't work otherwise. If I put a dot, it fails. Or should I just do it? Are you saying like just do it like this? Apparently this is the same, right? Okay. I was only writing it in lambda syntax because Lumi showed me it in lambda syntax, so therefore I wrote it that way. I'm not sure I fully understand why this is necessary and why I can't dot these together, but you know. But I can't remove this X, right? If I do this, this doesn't work. Yeah. I need to explicitly apply something here. Okay. This is kind of tricky. For me, anyway. I don't know what to write here. Okay, so Benjamin Franklin's Gout's back. I think it's going to be 75 people. Did it not update? It's because of the for alls. I suppose that makes sense, right? It's different than what I'm used to. I think it's 75. Did it come up or no? Why didn't it work? Hang on. Let me look at this real quick. I thought I saved it, but it seems to have not worked. Here. Here. Goal amount 75. Save. Oh, I see. I'm pretty sure I already have this. I don't understand why this is working on my screen, but it's not working on. It's not updating within OBS right now. I'm not sure how to get it to forcefully update or something. What if I hide it and re-show it? I don't know. I'm not sure why it's not showing Bredor. But I think it's going to be, I guess, 75. I wasn't going to do all the way to 100. And then maybe when we finish the affiliate application, we can have like a sub goal or something. I don't know. We'll see. Anyway, okay, so something about these for alls cause you to be more explicit. And if you aren't explicit, that causes problems. Now, I have a feeling that this one is going to be hard to actually apply to something. In this case, we should be able to test that this thing, maybe, is equal to I have no idea how we do this. So we need to apply, hey, stop it. So now we have an A. So this thing should just be equal to id x, right? And this has to be in parentheses. Oh gosh. Oh. That's not so hard. Okay, so that's how we deal with this. So this is how we would write a test for this. I'd like to actually quick check this because we can. This one looks like it's going to be harder. Although I guess not. I mean, I just have to say basically the same thing, right? In theory. Cool. Here. And we probably need eq a. Well, we need eq that whole thing. Guess it's this whole thing. It seems to think that we can as long as we use this flexible contents thing. So, I mean, we'll try it. If we can't do it, we can't do it. But, you know, I kind of want to quick check these things if possible. I think it's under there. If we can't quick check it, we can't quick check it. It is what it is. Yeah. Yeah, it's not good. There's no way, I suppose there's no way to solve this constraint. I imagine that's the issue. Okay, so we can't test this one. And we will move on with our life. We can only think about it. Which is fine. I do think I understand, or I can see that if A is R, then this is going to work. Yeah, I mean that makes sense. How would you compare a function? How would you equate two functions? You have to apply them. I have to apply them to something. What do I have to apply them to? Okay, we can write this function, I think. But how? Can we? Yeah. But it wouldn't make sense to equate those things, right? We can't actually, we need to turn this into an R. So we're gonna have to do something like let callback equal id. So we're gonna apply this whole thing. I think that's what I'm doing, right? We have to apply this whole thing to id. But let's not think about this right now. So that x is, what is this returning to? Yeah, I don't think that we want to go down the equate path. We need to apply this out such that we end up with r, right? That's not how you plug in the definitions. Oh, that's okay. I don't know what I'm doing. So this whole thing, let me get rid of this again. Whoops. So this whole thing gives you a to r to r. What's up, Zorkadon? Okay, so what does this give us? Shouldn't this give us r? Let's find out. I don't think so. Seems to think it's an A. Yeah, so this is what I was going to do, is say this is equal to like this. Is this right? Huh? This is what I'm trying to do, right? I think this is what I'm trying to do. Nobody said anything. They're mulling it over. The verdict is not in yet. I feel like somehow we're cheating, but I don't know how. But I mean, we're explicitly giving, we're saying in run continuation that, you know, this callback here is id, so it seems like I can write id here and be okay. No one said anything, so I'm going to assume that we're all mulling it over, and I'm going to start trying to write the test to actually make sure that these things work. That's what we're going to try and do real quick. Okay? Yes, yeah. This looks correct, but we haven't actually tested it yet. So let's do that, because we know how to do that. I think your definition of prove is different than mine. What do you mean? I feel like my definition of prove was different than Sandy's as well, because it seems to me that I need to be able to show that for a bunch, at least 100 A's, and really all A's, that that's true. So, but how do I symbolically prove that these two things are equal? By just looking at this type signature? That's enough? I don't know how to prove this from a formal mathematical standpoint. Yes, you're right. No, I agree with you, World Sender. But I don't know how to prove that for all A's that these things are actually the same from a mathematical standpoint. That's my problem. You just plug in the definitions of Cont and run Cont. Okay, let's try that. We will try that. So you're saying, all right. Yes? Um, I would do equal type and then something like proof equal AB. I don't even know what proof equals REFL means here. Types, not terms. So now I need to replace run continuation. So it's going to take this whole thing, reflection. I don't even know what that means. I mean, I know what a reflection is. Yeah, that's what I thought, but I'm mulling it over in my head. Because yeah, it's like... F to F id. Types and values aren't completely integrated. Right. Okay, I see. So this is F. CB X id well, it's, I don't know how to write this correctly, but it's like id X. Is that right? So this is enough? I guess it's enough. Okay. I like this better. It feels like a proof. I feel like this is correct. Okay. So this is the... Oh, well, I wrote it there. I don't need to write it here. Right. So that's hilarious. Maybe we'll get there. My poor soul. All right. So this is like... All right, so this is something that I need to check out, parametricity, at some point. If you could find like a good blog post or something about it, I would love to read about it. Probably off stream, I suppose. All right. Let's go back to this definition. I need some help. Right. Oh, that right. This x is the for all. Um, I want to think of these in terms of the lambda. All right. You guys are talking about something I don't understand. Anyway, if anyone knows of a blog post or something about what you're talking about, I would gladly read it. I'll do it off stream though. Can we write this one as just yeah. Let's leave it like this. I think it's gonna be help. Okay. I don't know that that actually helped me, but that's okay. So what is this F? This F is the for all, right? This is very difficult to see in my head. This one actually was pretty easy. Thank you for telling me to do that one first. Introductory stuff here. Oh, yeah, okay, I know this guy. Cool. Okay. I bookmarked that. Maybe I can learn something from it. Okay, so somehow we need to think about this. I'm not sure how. So this F is this whole thing. Right? So if we apply this to id, don't we just get an A? What is this X for? Or what is this X? I think I'm like mixing two things here, aren't I? just apply that to x. Okay, let's just do that. Wonder if you can write undefined error unsafe. Yeah, I should just stop reading what you guys are talking about. Okay. And so continue is what am I doing wrong here? Oh. This is A? And this is id? It takes A and the callback. Yes? So A and the callback. So you just insert X here. And the callback is id. So id X. X? This step is a little strange to me for whatever reason. Yeah. Is this step right? I feel like it's right. But I'm apparently not very good at this. Because I'm just sticking X in for this F. Right? I think it's right. It's not right. Oh, well, okay. I mean, that's what I had before. The continuation takes those two things, right? It takes an A and a callback. Because this is really like... But you're only giving it the A. How? Right. This X is that explicit for all. No idea what I'm doing anymore. I'm super confused. No, I don't know what I'm doing. That's why World's Ender. I don't see how to do stuff like this. Ignore this stuff. Is this right? I'm supposed to plug in this here. I think. But then what do I do with this? I legitimately have no clue what I'm doing. Now you need... Okay, so you're telling me that I can't do this. This is the answer, but somehow to reduce this further, I need something else. And this apparently looks right. Why does this look right? I don't understand. I'm going to assume that you're correct and move on with my life because this... I don't understand how this works. This is correct, you're saying. I don't know what to do. I think I don't know what to do. We just end here? We're done? Okay, so I don't know what parametricity is, nor do I know what function extensionality is. So we're done, right? Because there's nothing I can do. I think we're done. Let's move on. There's going to be clearly a lot of stuff that I just don't know how to do. Yeah. So I guess that thing that you just did is the parametricity. Is that what that is? So if I understood that, that step would make sense. Is that the idea? I really wish I was a mathematician. Ruined my life by not taking enough math. I feel like. Okay. I should have took more math in my life. That's why I tell every student I encounter. We had a student in here a while back who said, they were nervous about school, and I told them, just take a lot of math. So you can learn apparently how to deal with this. Or did you guys learn this in school, or did you learn this on your own? Okay. I think one does not ascend to the grumpy game dev. That's hilarious. You have to ascend the ivory tower on your own. Sounds good. Maybe we'll ascend the ivory tower someday. I would absolutely love good references to how you are learning to do these things. Like, what are the right resources to learn this stuff? Because I would love to understand how to do this stuff, and I think that I have the mental power to do it. I just don't know how to do it. So yes, references, send them my way. Okay, so apparently we are going to define a functor instance for this new type. Mid tower with F sharp. All right. We're trying to ascend. Well, maybe not. We want to ascend the ivory tower. I do want to do that. I just think it's going to be really hard. I already think it's really hard. Learning CoQ. Okay. I know that that's a proof assistant. I've heard of that before. Okay, so this says hint. Use lots of type holes and an explicit lambda wherever you're looking for a function type. So I know we need something like this, right? The idea in this case, I don't even know what Isabel is. Now I want to, okay. I want to look up what Isabel. Germany? Interesting. Well, I guess it could be either then. You're either in Germany or England. Side quest. We do lots of side quests, but I don't think we're we're probably not going to do proof assistance. Although maybe we'll get into it because I do really want to learn how to do this kind of stuff. Okay. Anyway, what does this look like? I just want to see what the code looks like. I assume this is not what the code looks like. This is like, well, maybe it does. Is this what the actual code looks like for Isabel? Or is this just like a pseudo language? Whoa. Yeah. Okay. Anyway. Still somehow works out. Fair enough. Okay, that's what the code looks like. Interesting. Okay. I mean, if we put a help here, we're just gonna get B to R, right? Yeah. So what's the type of F? A to B. So if we do... Yeah, I really don't see how this stuff works yet. I really can't wait until my brain gets this stuff. Ugh, it's so frustrating. Can only get an R by calling A. Yeah. We have... I don't know. I don't like this already. I'm not thinking about this right. Read impossible? Oh, even harder, as in impossible. Okay. So this is what we're trying to generate. An R. We have a function that makes an A to a B. A function like this. The call... Oh, whoops. Interesting. Is this actually correct? I legit don't know. I mean, I guess it is. Interesting. Yeah, I'm still like my brain still doesn't wire this right. Like if you give me like lists and recursive functions, I'm totally comfortable with that stuff now. But there's still some issues with like this kind of stuff. Like when I look at this type signature, I see, oh, why isn't this giving me, right? I see A to R, and I think, oh, I want R. Um, but that's not really correct. I want to apply this to a function of A to B, I guess. So I get A to B, and then just turn that to an R. This is okay. I don't know that this is correct, but this type checks. Just out of curiosity, what were you thinking of? Right, I'm actually turning this first into A to B, and then to uh, uh, giving the callback B to R to get R. My brain does not think about this yet. I'm hopeful that someday this stuff comes naturally to me, but you know, we'll see. Interesting. Let's think about that one for a second. Assuming it type checks. Also type checks. Okay, this is a parametricity thing. Oh, right. It does look like that, right? You're kind of just flip-flopping. Okay. It looks like what actually I forget who it was. I think it was Benjamin Franklin's gout that wrote that. But I see what you're saying now. Because you're basically just swapping this BR in. Yeah, yep. Yep. Yeah. So this is what, well, there's some formal reason that one can do this, but that's what parametricity is. Like the application of parametricity is that you can do this swap of BR and AR essentially. I think I'm gonna write it this way because I don't know what parametricity is yet, but we'll come back to that because I am, you know, these are definitely things I want to learn. So I'm glad you guys are teaching me them. All right, so we are gonna have Cont of far. Oops. Apply oh, that's not the error. br.f.r.id. That's hilarious. Okay, so there's lots of ways to use parameter. Is that still the same logic? Like you're using the fact that these things are, is that how you say that? They are parametric, or their composition is parametric? Something like that is causing you to be able to think about this. I'm wondering what the right terminology is. All right, so this is gonna get an A, and we need to make an A. Oh, whoops. Yeah, so this is an A to an R, and then we just apply that to our A to get R. At least I think that's right. Okay. So now we have my goodness. So I think we want to take parametric polymorphism is something that a language fulfills. The for all is parametric polymorphism. Okay. So because we know that there's parametric polymorphism because of these for alls. And without the for alls, we don't have parametric polymorphism. So if we have a rank 1 function, we don't have parametric polymorphism. Is that correct? This wasn't hard to write, by the way. So that's kind of cool. It's getting easier anyway. Hopefully I said that right. You guys will have to tell me. You guys know. Have you seen how for all a to a has only one value? Alicia me, thank you for following. Are you the Alicia? I don't know if you want to chat, but you're welcome to chat. I think Alicia is a friend of mine. The for all is just. Hey. Yeah, you guys are over my head right now. Yeah, I think I understand what you're saying, Benjamin Franklin Scout. The only thing that can go in there is id, right? Because that's the only function that can convert all A's to themselves. A function is said to be parametric in its argument if it fulfills parametricity. All polymorphic functions in a parametric polymorphisms fulfill parametricity. Oh my goodness. 8 to 10 times in its own definition, right? I think this is sufficiently tricky to explain via Twitch chat. So maybe we should, maybe this is another thing where we should have like, I don't know. So there, but that's a runtime problem, I guess. Okay, so here's what I think I'd like to do sometime. I'd like to try this on chat or in on Twitch. What if you guys joined me in Discord and we had a conversation about this stuff in like here? What if we tried something like that? I think I need to understand a little bit more about this, so I'm going to read that paper you sent me. I don't know how to do it, but we can think about something like that. You can live share with VS Code. That's interesting. I didn't know you could do that. Original paper by Reynolds, then Wadler. Okay. I'll keep reading. Okay, here we go. Is this right? Mm. Do I have this backwards? I think I do. Yeah. Okay. Yeah, yeah. Again, sometimes I catch it before you guys catch it, only because there's a delay. You guys see it in real time, and I probably think, "Oh, wow, he's wrong," and then I just happen to beat you to actually typing it, but only due to the delay. I actually don't know how long the delay is. Probably a few seconds, maybe 10, 20 seconds. Okay, so this needs to be. So we probably need to apply R to FACB. That's it? $40 because of your internet. That could be. I don't know how you measure it, so. Or I don't know if I could keep track of it somehow. The delay, that is. I think it's all on Twitch. Is this really it? Yeah. I feel like this isn't actually as hard as I thought it was. Yeah, I think the key is 2.5 seconds. Oh, that's actually not bad. I thought it would be worse. I mean, I do have the GTX 1060 Ti, I think. So with the NV encoder, it's pretty fast. And then, as long as I'm get a decent internet connection with Twitch, it's okay. Um, I don't feel sufficiently blown away by this. The parametricity stuff I feel sufficiently blown away with. Like, this is really hard for me. This is very difficult. This one was not terribly hard. I'm glad you guys showed me this quite a bit. Um, because, thinking about these in this situation and only comparing like 100 situations is not sufficient, right? Like, we can use algebra to solve our problems. Well, algebra and lambda calculus, I suppose. Um, so thank you for showing me this. I don't know why I was so scared of this. I felt like I was scared of it or something. But this isn't terribly hard. I don't feel uncomfortable with it. Yeah, that's actually a good question, World Center, because I always just use the regular Twitch thing as well. So now I'm curious too. If there's a less latency version, that would be useful. Okay, so I need to read a little bit, so bear with me because this is going to be going to take me a little bit of time. So this is great. All right. So one of the big values of continuation monad instance is that it allows us to flatten JavaScript style pyramids of doom. There's a tobacco pipe and an evening jacket. I can go get a glass of bourbon if that counts. But I don't have. Oh, okay. VLC plus stream link. How do you chat? Are you using like Chatterino or something? Where's my fireplace? Man, it would be sweet if I had a fireplace in here. I would love to have a place with a fireplace. Should I rub my beard? Does that help? Oh, yes. Yes, Pyramids of Doom. It's not big enough. Anyway. So, for example, imagine the following functions all perform asynchronous I/O in order to compute. Has anyone worked with JavaScript Pyramids of Doom? Does that mean something to anyone in this chat? Because it doesn't mean anything to me. I'm just curious. Oh, I guess we're gonna write it. Hang on. Okay, let's say. So. Callback hell. Yeah, they call it Pyramids of Doom, but you'll see it. It looks like callback hell to me. If I was to define callback hell. So. Yeah, I'll show you what he means specifically. Okay. I've never actually written JavaScript more than just like really, really stupid applications. I don't know why we're picking this number, but. Yeah. Okay. Grab a sip of water here. So what is this for? What are we trying to accomplish here? We're trying to make an R from a double, or an R from an int. Why are these called with OS, with timestamp? What's the point here? I'm not sure. My understanding is that we're going to compute these asynchronously and do something with the value. I see. Okay, this probably is going to help me by showing you this function every time. I get it now. Why did I write date? Oh, I see. Because he wrote date. That makes more sense. Let's just do this. Okay, so apparently this is called callback hell. So you write, I mean, imagine if you needed 30 of these things. That would be really problematic. And look terrible. And also, I suppose, if you have this situation, you can't do this asynchronously, right? The with is a convention for functions taking callbacks, although they're usually monadic and do some kind of the with. What do you mean by the with there? The prefix. Prefix. Oh, the prefix with is a convention for functions taking callbacks. I got you. I got you. Thank you. This with. I got you. Thank you. It's amazing how difficult it is sometimes to infer context from chat. But luckily, you guys are nice enough to clarify. Okay. So apparently you can write this same thing using a continuation function, or the continuation monad. Okay. So it says we can use the continuation monad or the Cont continuation transformer if they actually are doing I/O. So we can rewrite this as release, wow, string continue string release. I like that. That's funny. You got me there. I see. Okay, so the only question I have here is these aren't evaluated asynchronously, right? they're just using that as a motivating example. I suppose Haskell can decide if they run asynchronously, right? As long as they're all available when we're ready to go, because they don't have any dependencies on each other than this dependency. I don't actually know a lot about the GHC runtime, but I know that it can make decisions about computing things in parallel if it can. I do not know if this is one of those things. I think continuation implies sequentiality. Okay, that's good enough for me. So we would have to do this differently if we wanted it to happen asynchronously. All right. So when written in continuation passing style, release string Cont hides the fact that it's doing nested callbacks. There is also a monad transformer version of Cont. Implement it. Fun. Okay, let's see if I can remember how to do this. So first of all, I need to go get... No, I don't. I can just define it. But how do I define it again? Let's see if I can pull this. I don't think we can do this with a new type. I forget how this works. So monad transformers I'm not super keen on still, so sorry. I'm not very comfortable with how these things work yet, so we will go figure out how to do it by looking at our old code. By looking for what? Probably reader T. Oh, this is that horrible thing that we spent way too much time on. Here we go. These aren't the ones... Okay, so what am I thinking about here? So we need to... So we need an M and an A? Where does the M go? Does the M go in here? Is it going to be A to R to MR? I wish there wasn't the actual instance. So I think it's like this. Someone can tell me if I'm wrong. I think it's like this. I'm going to give people a few seconds to say yes or no if they think this is right. But what does implement it mean? I don't know what implement it means. Does that mean almost? Is there supposed to be another M? Is it A to MR, MR? Like this. Okay. I don't know what implement it means, so I'm going to look at the sheet and try not, or I'm going to look at the answers and try not to actually read the answers. Okay. Yep, that's right. Why is this all of a sudden happening? I don't know what this is about. Yes, that's right. So, oh well, that's unfortunate. Implement it means, and apparently I need to allow this. That's interesting. Oh, run would probably be a better name for this. That's fair. Yes, and yes, that's correct. And it can be a new type. Doesn't have to be data. Okay. Unfortunately, apparently these instances are really easy to write. I just noticed that you have this embedding. Wait, isn't that Cont exactly the same? I think he wrote an extra equals in there on accident, maybe? Unless I'm missing something. Yes. Yep. This is what he writes in the book. I can tell you that. That part I know. Apparently these instances are very boring, though. Mm-hmm. Mm-hmm. Oh. I think I was thinking about it right. But we have a type error here. Need something. All I meant by boring is the way it said this was that these are the functor, applicative, and monad are like exactly the same, but clearly they're not exactly the same, right? Because the types don't work out if they were exactly the same. Yeah, that that's more accurate. Because I think you need to say, you know, this, probably this one, to make this work. Yeah. So you need to know that this is correct. I want to look at the types very carefully here for a second. I need constraints on M. Oh, it needs to be a monad, right? Otherwise, they don't compose, right? Or does it just need to be a functor? I think it needs to be a monad. I haven't thought about this in a while. It just needs to be a functor. You just need to match the level. Yeah. Oops. As long as M is a functor, then Cont Tm is a functor. That's the idea. I mean, if you remove it, it seems okay, but it might fail the laws. For functor, you don't need anything. That could be right. I really don't know the answer to that. It doesn't complain. But maybe it's just the way the continuation works. Because you're not actually using an F map here. You're not F mapping over M of R. Yeah, exactly. Exactly. If I used F map, then it would need to be a functor. Okay. We could test it, I think. I don't know how. It would be hard, I feel like. Okay, let me look at these types again. Sorry. So we're taking an A to B to MR, and this takes A to MR to MR. Okay. And this is part of its parametricity. Okay. I'm okay with that. Excuse me. So it's going to be like FAB MRMR. You are only, if you want to say so, precomposing the continuation in your F map. It doesn't need the functor laws for M to work out. The laws for Cont M. Precomposing. Okay. Recomposing the continuation in your F map. I don't want to write this, by the way. Let's just write it like this. I'm trying to digest that. Give me a second. Ah. Here, I will need applicative, right? Because I need to use pure for M, I think. This version, more commonly called codensity. I've heard that term before. I guess I don't need this. Maybe I need something. Oh. Okay, this is apparently fine, so I don't need this. I don't think. Did he invent the name codensity? What is it? Is this a Kappa cat? Kipo. I don't know that one. That's a meme I don't know. Oh, I need to use BR somehow. I'm guessing this is going to be the same issue as before, where you need to stick BR in here. No. How did I do this before? I had it. Let's just write it this way. Let's see what. Yeah, so this is the same error. So then we need to do this. No, we don't need to do this. Okay, need to think about this more carefully. Let's stick a help in here. Just C. Okay. That's less helpful. It would be hard to talk about. All right. This is in fact B to MR. Hmm. Mm-hmm. So we need to compose BR and Faber. Oh. Okay. This needs to be a B. What did I do before and why did it work? Because this gives me a B. But now I'm getting an MB. Do I just need an F map? Just like the functor instance, I can't start with the BR. Okay. So this one works. Oh. As you can see, I really want to start with the BR. So essentially I need to compose two functions that give me, you have to compose BR with something. And it's got to be the Faber. I feel like it's got to be but this doesn't work. Why doesn't this work? Good. Hmm. Now I'm just guessing. It's not good. I'm not thinking. I'm getting very tired. That's B to MR. Sorry guys. I'm falling. My mental state is going. Oh my god. I mean, I'll try it, but if it works, I'm gonna be depressed. We can try and write it a different way, I suppose. God. I hate you. There has to be an easier way to write this, right? I hate it. It means literally nothing to me. I already forgot what I said, such that the response was don't be. But anyway, I feel like this is really difficult. I imagine this is something that somebody was trying to write to be cute, right? But anyway, we can try and use this to develop our solution, I suppose. So if we want to make this explicit, let's put this under here. Okay. So that would mean that we would write it's either this way or this way, right? How do you translate this? I already tried this, so I don't know how to translate that. Let's look at the types. Maybe they mean something. Oh, you're nesting. Do you just know that you need to nest them? I'm genuinely curious because I'm having a hard time with this. But it's supposed to be okay. This one's a lot harder. Although maybe he wrote the answers to these other ones in a different way, and maybe the ones I wrote are wrong. So yeah, I'm nesting. Come at me. Come at me, bro. I'm fine with the nesting. I'm just trying to understand the logic of how you got there. The other thing I want to look at is his implementations of these, and if I'm way off. I want to look at that real quick. Yeah, his solutions are different than mine. I'm wondering if mine are wrong. He uses exactly what you just wrote there for the applicative instance of this one. I'm not convinced that this is correct. But I don't know how to just look at it and know that it's not correct. Do you know what I mean? I think nesting is the correct way to do it. I'm not sure where to go from here though, because this all seems to be fine, but Again, that only means the types are working out. It doesn't mean that it's working as expected. And also in here, okay, let me put my cursor here. Natural for me to either use Fabr or far to produce the R I want. So I start with and see what I get. See what I get. What do you mean, see what I get? Wish this stuff came naturally to me. It'd make life a lot easier. Anyway, I don't think these are correct either. This one might be correct, but I don't think this one's correct. And I don't think this one's correct either. We'll come back to that. I really would like to finish for the night. I am so tired. So let's put a note in here. Streaming twice today was maybe not a great idea. Need to compare these carefully to the answers provided in the book. Okay. I think I'm okay with that. Nah. This one's not gonna type check again, but Sorry guys, I'm having a hard time following right now. This is a nested. So this is actually no, because it's inside the monad. This is MM. This is really painful for my brain. So wait, is that not correct? Then if I wrap this in Cont T, doesn't work? Do I need to apply this to something? I can't think right now, guys. I'm just bad at this, I think. I need so much more practice with this kind of stuff, and I don't know how to get it. Like, how do I get more practice with this kind of type rodeo? That's what I really need. I just need to do, maybe what I should do is like pick a set of problems and then just implement them like once a month, so I can think about this more carefully. But if I do it in a month, I think that might be long enough that I won't just memorize the answers. Something like that might be really useful. Okay, I'm gonna get some motivation because my head is, I'm done. My brain is so done. Yeah, it's not, this isn't going well for my head right now. We're going to sit down and really think about these very carefully. So the real question is this one, this one's right, Yeah, this one's right. This one is, I think it's right. A, B. Yes, that one's right. And this is what the answer is according to the book. Now, so there's some questions that are still, that we still need to think about. So why the heck, or not why, how do these work? So the question is, how do these work? Or not, maybe not how is a bad way to say it, but you know, why are the types working out? And is there any way I can think about it more carefully? If I put a $sign here, I can do this, right? I don't know if that's cleaner, but I'm just trying to split stuff up a little bit. So why did the types work here? And like, we need to have a nice functional understanding of this, but I'm shot for the day. And then also we want to go back and make sure we understand it. Do these actually work the way we think they do, or are the types just working out? So I think this one's correct, but I'm worried that these two are not correct. So we could test them, something like this. I'm not really sure, but that's what I want to do when we come back next time. But for now, I think we're done for the night. I'm very, very tired. So I apologize if that was really lame towards the end because of my, I don't know, whatever this is.